Okay, so today what we're talking about is we're starting chapter 3, and our Common Core standard really is solving systems of equations consisting of linear equations graphically. Okay, that's the Common Core standard, okay? We went through our reading, we talked about basically what we're looking for is two lines that intersect. And if they intersect in a point, then we know that it's going to be an independent system, okay? And the point is the answer, okay? If two lines are parallel, they will not intersect. So the answer is going to be no solution. Okay, and we talked about that's an inconsistent system. It is possible to have two lines of the exact same lines and overlap, and they intersect everywhere. So they have solutions as all real number solutions, and those are called a dependent system. Okay. Now, 7. How do you verify a solution? Well, we're going to do that really quick in our first example. You plug in both the answer x, y into both equations, and you should get a true statement or a true answer. So let's take a look at our first example, okay? Example 1. Let's verify that 2, 4 is a solution. So, before we go any further, the 2 is an x value and the 4 is a y. Every point's an x and y, right? So how do we verify it? Well, we just read that you're going to plug it into both equations. So the way I like to do it is I like to write x minus 2y equals 4 here, and I'll write the other equation next to it, 2x plus y equals 8, okay? So it says plug into the answer into both equations and get a true answer. So what I want to do is I want to plug in 2, 4, and it better equal 4. I want to plug in 2, 4, and it better equal 8. If it equals a true statement on both, then yes, this is a solution. Alondra? Oh, thank you, Alondra. I would have made a mistake. Thank you. I don't know. Thank you very much. Okay, so let's plug it in. So I'm going to plug the 2 in for the x. So I'm going to go 2 minus 2 times. I'll plug the 4 in for the y. And will that equal negative 6? Thanks, Alondra. It probably wouldn't have before, huh? So let's do the math. Let's see if we get this to equal negative 6. So I just plug the x and the y into the equation. So I get 2 minus 8. Sure enough, 2 minus 8 is negative 6. So I'm going to say T for true. That's true, right? I need this to be true also to say yes, that solution has to work for both, not one or the other. Has to work for both. Has to work for both, okay? So let me plug in my 2, 4. I'll go 2 times my 2 plus my 4 equals 8. Well, let's see. Am I going to get a true statement? Sure, I get 4 plus 4, and we know 4 plus 4 is 8, okay? That's a true statement. So if it's true for both, we can say yes. Yes, the point 2, 4 is a solution, okay? So 2, 4 is an answer. It's a solution, okay? That was easy. We just plugged in both x and y values into both equations, right? If it worked, if we got a true statement both times, yes. If you get a true on one and not on the other, it's no. Okay, it has to work for both. All right. Now, example 2. Let's find the solution of the system by graphing. So now we want to actually get the answer, but let's graph it first. So if I'm going to graph the system, what I like to do is first to solve for y, right? And we did this last chapter, we graphed, so we should be getting pretty good at it. I'm going to call this equation 1, equation 2. It just makes it easier because when I talk about an equation, I say, well, this is equation 1, this is equation 2, okay? So let's write it out. I've got an x plus y equals 4, and I'll have a 2y plus 4 equals x. So if I have to solve for y, to graph it, on the first equation, equation 1, just going to go minus x, right? So put minus x, and I get y equals a 4 minus x, okay? I'm going to graph that in a second. To make it easy for me, I'm going to put a 1 over 1, instead just so I know my slope, right? I put a 1 over 1, because negative x, same thing as a 1x over 1. So I can start at 4, 1, 2, 3, 4, and I'm going to apply the slope, which is down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, so forth and so on, right? And just connect the dots. All right. Second equation, Bring over the 4, so I'll subtract the 4, right? Minus the 4, minus the 4. So I'll have a 2y equals an x minus 4, right? Divide by 2, divide by 2, divide by 2. I'll have a y equals, let's make that a 1 for a 1/2 x, so a 1x, right? A 1/2 x minus 2, right? So I just solve for y so that I can graph them. So start at -2, that's there. Go up 1 over 2, up 1 over 2, up 1 over 2. Graph my line. Now, I'm staring at my answer. I need to write it down. I mean, I'm looking right at my answer. Sure enough, everybody agrees my answer is right there. You guys agree? My answer is that point. So my answer is the point 1, 2, 3, 4, comma, 0. That is the answer. The answer is the point that they intersect at. Okay, that's not bad. That's not that hard. Graph them. Find out where they intersect. And if they don't intersect, then we'll talk about that also. Okay. Right? Everybody good? Example 3. Let's see if example 3 is any different. So first of all, in example 3, let's go ahead. Equation 1, equation 2. Let's do the same thing. Okay. Let's try and graph it. I'm going to write my 3x plus my y equals 3. And my second equation, I'll go 2 plus y equals a -3x. I have to solve for y. I have to solve for y to graph them, right? Got to get y by itself so I can graph, okay? So, in this case, I'm going to bring over the 3x. So I'm going to go minus 3x, minus 3x. So I'll have a y equals a 3 minus a 3x, okay? I might make that a 3 over 1. It's going to make it easy to graph. So I brought over 3x, so I've got 3 minus 3x. So I've got y equals 3 minus 3x. So I'll start at 3, 1, 2, 3, right? And my slope is -3 over 1. So instead of going up 3, I'm going to actually go down 3, 1, 2, 3, and over 1. Down 1, 2, 3, and over 1. Down 3 over 1. Okay, so graph my line. There it is. Okay, this one I have to solve for y, so let's go minus 2, and I'll get y equals -3x minus 2, right? So let's go down to 2, -2, and we'll go down 3 over 1, down 3 over 1. I'm running out of room, so I'll go the other direction, right? Okay. All right. Yeah, I heard it. So what do you guys know?
It's parallel.
Now, how do you absolutely know they're parallel? How come you don't think they might just slowly come together?
They have the
Same slope, right? Everybody agree? Because they have the same slope, we know for sure that they'll never ever intersect, so they're parallel. But parallel is not the answer. The answer is where they intersect. Where do they intersect?
Never.
Never. So how do we say that?
They say they're no solution.
No solution.
Yeah.
Or we could use this symbol, the empty set, okay? No solution, great. Yes, they're parallel, but that's not the answer. That's just describing what's going on. The solution is the fact that they have no solution, right? Okay, ready to turn the page? Okay, good? Okay, turn the page. All right, now, example 4, all right? Find the solution to the system, then graph. Same thing. What we're going to do is solve for y, right? So I've got my 2x plus y equals 3, and we'll do our 6x equals 9 minus 3y, right? Okay, let's go minus 2x, y equals 3 minus 2x. Okay, I can graph that, right? Start 1, 2, 3. Slope is -2 over 1, so I'll go down 2 over 1, down 2 over 1, right? Down 2 over 1, right? Okay, so for this one, okay. Second equation, I have to solve for y. So I'm going to go minus 9. It's just written backwards, but I can handle it backwards. You know, we know how to do it backwards. 6x minus 9 equals -3y, right? I just, solve for y. Even though the y is on the other side, the y is on the right-hand side, I can still do it. So minus 9, now let's divide by -3, divide by -3, divide by -3. I'm going to get a -2x plus 3 equals y. Same line, isn't it? Same exact line. So if I were to graph that one, same exact line. Okay, so that's not the answer. The answer is where. Hold on, wait. There's no. Just it's the other one. It's the other one because they intersect everywhere, don't they?
All real.
Yeah, it's all real numbers. Or we can use the cursive R. Okay. All right. Last one, example 5. Big dog, snowboard, and Halfpipe. Okay. I did not make these names up. These came out of the book. Okay. It's all good. So a big dog charges $15 for equipment rental plus a $35 per hour. Okay. So this is a one-time charge, like a fixed cost, and this is a per hour. Okay. So I'm thinking, all right, if we're going to do an equation for this, first equation to have is like, okay, so cost is going to equal, I think I would go with 35H plus 15. You okay for the cost of that for big dog? $35 per hour, $15 for equipment rental. I mean, you get your equipment, it doesn't matter how long you ski. You know, they charge you by the hour to ski, not for the $15. $15 is for all day. Everybody agree with that? Okay, now what about Halfpipe? What is their equation? Cost equals, what's their cost? What's the cost? 25H, yep. 25H plus 40. So their equipment rental is more, but their per hour is going to be less. So, I mean, initially, if you're going to spend like only an hour or 2 hours skiing, Halfpipe is going to cost you more, right? I mean, if you're going to have a short day, I wouldn't go to Halfpipe because they're going to get $40 off you right at the bat. I'd go to Big Dog because Big Dog is like, even though they're higher per hour, if I don't ski that long, I think I'd save money going here. But if I ski for like a weekend or a week, well, Halfpipe's probably going to be cheaper, right? Definitely, okay? So let's go ahead and figure it out. So let's go through it. So 0. And I'm going to use my calculator to plug them in because it's easier to use my calculator. So I'm just going to plug in 0, 1, 2, 3, and 4. You guys see that on there? Yeah. So right off the bat, on, clear. I'm going to go 35 times 0 plus 15. So for, you don't ski at all, you pay your $15. You break your leg, you come right back in, you only own $15, right? You didn't ski at all. Okay, but let's go for 1 hour. Okay, so we're going to go our 35 times 1 plus my 15, $50. Okay, skiing is way too expensive, by the way. 35 times 2 plus my 15, right? $85. All right, let's plug in 3. 35 times 3 plus my 15, 120, and then we'll stop there, okay? Now, Halfpipe. Let's check out Halfpipe, okay? So if I go 0 hours, it's going to be 40, right? You get your skis, you step out of the lodge, you slip and you break back. Got to give back your skis, right? Bad day of skiing, right? Let's do 1 hour, 25 times 1 plus 40. You ski for 1 hour, get cold, and wimp out. Return your equipment, right? $65. And then we're going to go, same thing, we're going to go 25 times 2 plus my 40, and I get an answer of 90. And then I'll do my 3. I'll do my clear 25 times 3 plus my 40, and I get an answer of 115, okay? So, what do you see? Initially, Halfpipe was more expensive. You guys agree? But right about 3 hours, all of a sudden, it costs less, right? So, for what number of hours are the two companies cost the same? What do you think? 2.5? You guys want to try 2.5? How can we, let's plug in 2.5. So let's go, always got a great idea. Let's do 2.5 hours, 2.5 hours and see if they're the same, all right? So I'm going to check it out. I'm going to add to my cost. I'm going to 35. Let's go for 2.5 hours. 2.5 plus 15, and I get $102.50. All right, let's check it out. Halfpipe. we're going to go 25 times 2.5 plus 40, and I get, sure enough, $102.50. Now, why do I even care? Why do I even care? Well, we're smart, right? We're smart. I mean, we want to save some money. So if my buddies and I, if I go and take Landon, when I go skiing with Landon, he likes to ski all day, right? So we would probably go with Halfpipe, right? If I find a cute girl to go ski with me, she usually gets cold and likes to sit in the lodge, I might rent from Big Dog, right? You never know. So it is kind of important. So you know that if you're going to ski for more than 2 hours, go with Halfpipe. If you're going to ski for more than less than 3 hours, go with this one, right? Okay.